The installation conforms to the outside tap rule described in NEC Article 240.21b5. This rule addresses situations where a smaller conductor is tapped from a larger feeder. Several conditions must be met for the outside tap rule to apply, ensuring safety and proper overcurrent protection. The general concept of the tap rule is to allow a smaller conductor to be used for a short distance, provided it is adequately protected against overcurrent. This is useful in situations where it is impractical or uneconomical to run a full-size conductor all the way to the load. Now let's break down the specific requirements of NEC Article 240.21b5, focusing on the outside tap rule. The outside tap rule allows for taps external to a building under certain conditions. Firstly, the length of the tap conductor. A critical aspect of the outside tap rule is the maximum permissible length of the tap conductors. The tap conductors must not exceed 25 feet in length. This limitation is in place to minimize the risk of faults occurring on the smaller tap conductors. The shorter the tap, the less vulnerable it is to damage in overcurrent situations. Secondly, overcurrent protection. The tap conductors must be protected from overcurrent by an overcurrent protective device, such as a circuit breaker or fuse. This device must be located at the load end of the tap conductors, typically within the panel board or equipment being served. The rating of this overcurrent device is crucial to the safe operation of the tap. For the tap conductors, it must be size no greater than the ampacity of the tap conductors. The ampacity of the tap conductors must be suitable for the load being served. Thirdly, conductor ampacity. The ampacity of the tap conductors is another key factor. The tap conductors must have an ampacity that is not less than 1/3 of the ampacity of the feeder conductors from which they are tapped. This requirement ensures that the tap conductors are adequately sized to carry a reasonable portion of the feeder's load. It prevents the tap conductors from being undersized to the point where they could be overloaded. Fourthly, physical protection. The tap conductors must be suitably protected from physical damage. This protection can be provided by enclosing the conductors in conduit, raceway, or other approved means. The type of protection required will depend on the location and environmental conditions. For example, underground conductors must be suitable for direct burial or installed in conduit. Fifthly, termination requirements. The tap conductors must terminate in a manner approved for the conductor and the application. This includes using appropriate connectors and ensuring proper termination techniques. Poorly terminated conductors can lead to overheating and electrical hazards. To reiterate, an installation conforms to the outside tap rule if the tap conductors do not exceed 25 feet in length and are protected by an overcurrent device not exceeding 100 amps for 60/75 degrees Celsius copper conductors or 80 amps for 75 degrees Celsius copper conductors. The overcurrent device must be located at the termination of the tap conductors. Let's consider an example, an application of the outside tap rule. A feeder starts at a switchboard with a 225 amp breaker and runs underground with number 4/0 copper THWN conductors. In an underground pull box, a tap is made with number 3 copper THWN conductors. These number 3 conductors continue underground for 200 feet and rise in a small storage building to a panel with a 70 amp main breaker. The conductors are protected in conduit their entire length except for the tap in the pull box, which has a locking lid. To determine if this installation conforms to the outside tap rule, we need to evaluate it against the criteria mentioned above. Firstly, length of the tap. The problem states that the tap is made in an underground pull box with number 3 copper THWN conductors and continue underground for 200 feet. It does not specify the length of the tap. However, it is not more than 25 feet in length. Secondly, overcurrent protection. The number 3 copper THWN conductors terminate in a panel with a 70 amp main breaker, serving as the overcurrent protection for the tap. This breaker is located at the load end of the tap conductors. The ampacity of number 3 copper THWN conductors is 100 amps per NEC Table 310.16. The 70 amp breaker provides adequate overcurrent protection since it is less than the conductor's ampacity. Thirdly, conductor ampacity relative to the feeder. The feeder conductors are number 4/0 copper THWN, which have an ampacity of 230 amps per NEC table 310.16. The tap conductors number 3 copper THWN have an ampacity of 100 amps. The tap conductor ampacity must be at least 1/3 of the feeder conductor ampacity. 1/3 of 230 amps is approximately 76.67 amps. Since the number 3 copper THWN conductors have an ampacity of 100 amps, which is greater than 76.67 amps, this requirement is met. Fourthly, physical protection. The problem states that the conductors are protected in conduit their entire length, except for the tap in the pull box, which has a locking lid. While the pull box provides some physical protection, it's important to ensure that the tap conductors within the pull box are properly protected from damage, such as by using suitable connectors and supports. In summary, the installation appears to conform to the outside tap rule described in NEC Article 240.21 B5, assuming the length of the tap is no more than 25 feet and the tap conductors in the pull box are adequately protected. It's always recommended to consult with a qualified electrical inspector to ensure compliance with all applicable codes and regulations. They can provide specific guidance based on the details of the installation and local requirements.